Picture this. It's a crisp October night in Hawaii. Above you, the dome of the Pan-STARRS telescope hums softly as its giant eye sweeps the sky. The job is routine, another night cataloging asteroids, comets, and cosmic dust that, for the most part, will never trouble Earth. But then a faint pixel. So faint, you could almost mistake it for a glitch, except it's moving. At first glance, it's just another space rock. But when you run the numbers, the hairs on your neck rise. The speed, way too fast for an ordinary asteroid. The trajectory, all wrong. It's not looping around the sun, it's skimming past it and leaving forever. And then the real kicker, this thing doesn't just pass by. As it leaves, it accelerates. No engine, no plume, no visible gas, just a subtle but undeniable push, like something is quietly helping it along. If this were a scene in a sci-fi movie, you'd think, well, here's the alien probe reveal. But this wasn't a movie. This was Oumuamua, the first interstellar object ever spotted passing through our solar system. And for a brief few weeks in 2017, it had every astronomer on Earth asking the same question. What in the universe is that? Let's rewind to the 19th of October, 2017. Robert Weirich, an astronomer working with Pan-STARRS at the University of Hawaii, was scanning the night's haul of images. Normally, identifying objects is a bit like finding ants on a sidewalk. Most are slow, predictable, and headed in familiar directions. But this streak of light, it was the cheetah among turtles. The initial designation was C, 2017 U1. C for comet, because when in doubt, comets are a safe bet. They're icy bodies that flare up when they get close to the sun, releasing gas and dust in spectacular tails. Except, follow-up images from observatories worldwide saw no tail at all. The C was replaced with an A asteroid, A 2017 U1. But even that didn't stick. Asteroids, like comets, are bound to the sun's gravity. Their orbits might be eccentric, but they always come back for another lap. This object, its eccentricity, the measure of how stretched an orbit is, was 1.20. Anything above 1 is unbound. In plain terms, it came from outside the solar system, and it was never coming back. For the first time in human history, astronomers were looking at an object from another star. The International Astronomical Union created a brand new classification, I for Interstellar. And they gave it a Hawaiian name, Oumuamua Scout, or Messenger from Afar. Now, I know what you're thinking. Okay, so it's just a rock from another star system. Cool, but not earth-shattering. But you have to understand, before Oumuamua, this was purely hypothetical. We knew that other solar systems probably ejected debris all the time, just like ours does, but spotting one in the act, that was like catching a grain of sand in mid-flight between two beaches. And here's the thing about one-of-a-kind discoveries. They always seem to hide just enough to drive you crazy. By the time we spotted Oumuamua, it was already past its closest approach to the sun and heading out. That meant astronomers had a 40-day window to gather every scrap of data before it faded into invisibility. Think about that. 40 days to study the first ever interstellar visitor before it vanished forever. The pressure was enormous. Observatories around the world pointed every instrument they had at it. And what they found only deepened the mystery. Oumuamua's light curve, how its brightness changed over time, was wild. Every 7.3 hours, it would brighten and dim by a factor of 10. That's huge. Most asteroids show changes of maybe 20–30%. This meant it was either very elongated, like a cigar up to 10 times longer than it was wide, or extremely flattened, like a pancake seen edge on. It was also tumbling, not spinning neatly like a planet or moon. And here's where things turned from weird to what the p. After passing the sun, Oumuamua started to speed up just a tiny amount, about 5 millionths of a meter per second squared, but enough to be measured with certainty. Comets can do this when sunlight heats them, releasing jets of gas that act like rocket thrusters. But Oumuamua showed zero signs of outgassing. No tail, no halo, no dust. no heat signature in infrared scans. Solar radiation pressure, the push from sunlight, was another candidate. But for that to work, the object would have to be extremely thin with a huge surface area relative to its mass. Something like a light sail, the kind of technology humans have been experimenting with for decades. Now, I'm not the kind of person who slaps the alien label on every mystery. Most of the time, nature has an explanation, even if we haven't figured it out yet. But when Avi Loeb, a respected Harvard astronomer, suggested that Oumuamua could be a piece of alien tech, perhaps a defunct light sail drifting through space, I couldn't help but perk up. Because think about it, if you were an interstellar civilization sending probes, you'd probably use light sails. They don't require fuel once deployed, they're perfect for long voyages. And they'd look exactly like this in our telescopes. Fast, thin, highly reflective, and weirdly non-comet-like. Of course, there's a less exotic theory: hydrogen icebergs. Astronomers Daryl Seligman and Jennifer Bergner proposed that Oumuamua could be made of water ice saturated with molecular hydrogen. Cosmic rays in deep space split hydrogen from water, trapping it inside. Then, when the object nears a star, that hydrogen escapes, providing thrust but no visible tail or heat. It's a clever explanation. And since they proposed it, other dark comet candidates have been spotted in our own solar system. The debate is still fierce. Loeb argues the hydrogen model doesn't match the cooling physics, while others say the light sail idea is speculative at best. Then, in July 2025, something incredible happened. The Atlas telescopes in Hawaii and South Africa spotted 3I Atlas, only the third confirmed interstellar object ever. Unlike Oumuamua, Atlas looked like a comet from the start coma, outgassing the whole package. That's important, because now scientists have something to compare. If Atlas behaves like Borisov, our second interstellar visitor, and Oumuamua doesn't, that tells us Oumuamua really was an oddball. The Vera C. Rubin Observatory, operational since mid-2025, will scan the southern sky every few nights. It's like a cosmic security camera that never blinks. And when the next interstellar object shows up, we might catch it before it slingshots past. That's when missions like Project Lyra could come into play, spacecraft designed to chase or intercept these visitors. With enough warning, we could actually fly alongside one, study it up close, maybe even sample it. Here's where I let my imagination run wild. What if Oumuamua was a probe, long dead but still drifting? What if it was a message in a bottle, tossed into the galaxy's currents eons ago? What if, and this is my favorite scenario, it wasn't meant for us at all, but for someone else, and we just happened to intercept it? And what if we missed the important part, like finding a USB stick but never plugging it in? For now, the odds say Oumuamua was natural. But odds aren't proof. And until we touch one of these things, or see dozens more, the mystery remains. The universe doesn't owe us answers. But it does keep sending us questions, faint pixels gliding across the night sky, daring us to notice before they vanish. So the next time you hear about an odd object passing through the solar system, remember Oumuamua. And remember that sometimes the rarest visitors are the ones who leave the most unanswered questions.